Hey kids, welcome to Pre-Algebra's Ratios and Proportions video. I am being interrupted currently by a kitty cat. So let me just tell you, it has been a week. My little family of 3 got the flu. And then when we were finally starting to feel better, a little bit better on Christmas Day, our refrigerator died. And we had to go about 4 or 5 days without a refrigerator, which was a really long time without a refrigerator. But anyway, very, very thankful that we are able to take care of that kind of thing for ourselves, and feeling very thankful right now for electricity and refrigeration and modern medicine. This flu is no joke, children. Wash your hands. Now, that's a good 45 seconds of video that I've taken up telling you about my stuff that's been going on. I apologize. Let's jump into doing some math. Alright, ratios and proportions, we've already used both in class a little bit here and there, but we're going to go ahead and make sure we understand everything, go over some definitions. So a ratio is a comparison of two numbers by division, and usually you show a ratio as division, as a fraction, 5 to 2, 5 over 2, which is the ratio of 5 to 2. You can write it with a colon, or you can write 5 to 2, which is how you'd say the ratio 5 over 2 is 5 to 2. So a ratio is a comparison of those two numbers by division. We use them for all sorts of things. A fraction is a ratio, it's a division problem, and it's a fraction. So that's something that you want to think about. You know, that's different ways to think about this one thing here, this one value. This could be a ratio of 5 girls to 2 boys in a room, or 5 boys to 2 girls in a room. Could be anything. Could be 5 pineapples to 2 something else, which brings me to a rate, which is a comparison of two quantities with different types of units. So that would be if we had a situation we had $5 for 2 pounds. That would be a way that this ratio of 5 to 2 could be a rate with two different units. $5 for 2 pounds. Now, if you take that and you simplify it so the denominator is a 1, you get a unit rate, which is where you have per 1. And so that would be like when we look at, feline, excuse me, I have a cat clawing my leg for attention. Sorry, that doesn't happen when I make videos at school. Okay, so over here we have the price of gas. So when we say a unit rate, so when we say $4.29 per gallon, we're saying per 1 gallon. That's what that amount is, and that's what a unit rate is. And so you can have a unit rate that can be the cost of gas here. We could go back up here to our example with this, and that's $5 for 2 pounds is $2.50 per pound. So that's an example of a unit rate. A student-teacher ratio, or in this case, student-to-teacher ratio, 8 to 1. So 8 students per teacher, which would be a tiny student-teacher ratio. I don't know what kind of school would actually have that. We clearly don't, but 8 to 1 student-teacher ratio. You could have the rate at which snow is falling. So you could have, hold on, let me get a color you can actually see on this background. You could have 4 inches per hour, which would be a pretty sweet snowstorm. I would love to see a little bit of snow coming up soon. But these are all rates, unit rates, and when you think about a unit rate, you've got those two different units, but the denominator one is a 1, and that's what a unit rate differs. That's how a unit rate differs from a rate. All right? An equation that's made of two equivalent ratios is a proportion. And so this is now when you get to the point where you have two ratios that are the same. So let's look, for example, at, let's think 4 over 12, or 4 to 12, and 2 to 6. Okay, 4 to 12 and 2 to 6. Both of those are equivalent ratios. In fact, what they're equivalent to is 1 to 3, if we simplify it all the way down. And one thing I want you to notice about equivalent ratios, about these two values that are equal, just look at one pair of them at a time. If you cross multiply, so if you take and you multiply together the numbers diagonally, so 4 times 6 there, and over here we got 12 times 2, those cross products, they are equal. So cross products in a proportion are equal. Cross products, and that's when you diagonally multiply in a proportion. And those cross products are always going to be equal. Look at the other proportion that's formed here. 2 times 3 is 6. 1 times 6 is 6. So 12 times 2, 24. 4 times 6, 24. We use this fact right here. We use the fact that these cross products are equal. We use this fact to solve proportions. That's how we actually solve them. So there's 3 steps to solving a proportion. First, you're going to cross multiply. So you're going to multiply diagonally. Then you're going to set the cross products equal to one another, and then you're going to divide to solve. So what happens is you get a proportion like this one, where you have the 2 sides are equal, okay, but one of these 4 values is missing. And that's what you have to find. Now, sometimes you're going to be able to do it mentally, but this will always work. So sometimes we can do it with mental math, but this will always work. Let's try some examples. All right, my first proportion, x over 4 equals 9 over 10. So we're going to cross multiply. So that means we're going to multiply x times 10 and 4 times 9. So x times 10 is 10x. Put the number in front, coefficient in front of the variable, please. We set that equal to 4 times 9, which is 36. So our cross products are equal to one another. Cross products are equal. And then we divide to solve, because what we have is a one-step multiplication equation, and you solve that with division. Now, we're going to be working with percents pretty soon, and I want you thinking about tricks with tens. Remember, when you divide by 10, that's taking a decimal point and shifting it back one place. So this answer comes out to a nice happy 3.6. Not at all hard. 36 divided by 10, 3.6. Because dividing by 10 is just shifting a decimal point. And that's how you solve a proportion. So if you've understood that comfortably and you want to go ahead and haul right through these, go for it. But I'm going to go through them one at a time. All right. So again, we're going to cross multiply. D times 2, 7 times 3. So 2D equals, and 7 times 3 is 21. So clearly I didn't give you any of these that would have a whole number answer, apparently. And then, like we said, divide, because it's a multiplication equation, and those 2's are going to cancel right there. You're left with 10.5. So D equals 10 and a half. Because when you divide 20 by 2, 20 in half is 10, and 1 in half is 1 half, or 0.5, so 10.5. And the last one, I'm going to cross multiply. So 2 times y, 2y, equals 5 times 34, which is 170. So I think we finally found one that's going to come out to a whole number. So 34 times 5, 30 times 5, well, that would be 150. And 4 times 5, that would be 20. Yep, 170. Just had to double check. Divide both sides by 2. Dividing by 2 leaves me, well, half of 100 is 50, half of 70 is 35, 50 and 35 is 85. So y equals 85. And you can double check your math by going back and cross multiplying. Don't go back and write anything here. This is your answer, because you are looking for y. This is your answer. Okay, you're looking for D. This is your answer. Don't go back and erase and rewrite it in here. Just leave this. So your answers are the values of the variable. So this is a really useful skill to have. We're going to find lots of problems that you can solve using proportions. I use them all the time. Use them all the time in just simple everyday math. If you did any baking over the break and you had to enlarge or cut down a recipe, you probably used a proportion to figure that out, or at least the folks that were giving you the ingredients did. So let's look at a couple quick word problems. Number 1, 6 pounds on Earth weigh about 1 pound on the moon. If a person weighs 96 pounds on Earth, what would he weigh on the moon? So, again, remember we talk about the difference between weight and mass in science. Remember, weight is about gravity. Mass is about how much matter there is there. So when we talk about how much you weigh on the Earth and the moon, now your mass hasn't changed, but the gravity changes. And so that's why you're going to see a difference there. So let's look at this situation. 6 pounds on the Earth, 1 pound on the moon. If you weigh 96 on Earth, what would you weigh on the moon? Now, this is kind of like an analogy, and you see analogies all the time in English. Hot is to cold, as left is to their opposites, so right. All right, and so that's kind of what you have with you have a proportion problem. 6 pounds on Earth weighs 1 pound on the moon. That equals the ratio of 96 pounds on Earth would weigh I don't know how many on the moon. And there you have your proportion that you can now cross multiply and solve. So our cross products are 6x and 1 times 96, which is 96. We divide to solve, and let's see, 6 goes into 9 one time, with 3 left over. 6 goes into 36 6 times. So we end up with 16 pounds. So if you weighed 96 pounds on the Earth, you'd only weigh 16 pounds on the moon. It'd be really easy to jump really high, I would imagine. Of course, you'd also have a whole bunch of equipment on because you can't breathe on the moon, but that's beside the point. So let's look at another example. A running example. I got a treadmill for Christmas and my birthday, which is coming up. Very nice gift from my mother, so I'm pretty excited about being able to use that to go running when it's nasty outside. Anyway, say that you run 3.5 miles in 40 minutes. How long should it take you to run 8 miles? Again, think about my analogy example up here, okay? 3.5 miles in 40 minutes equals 8 miles in I don't know how many minutes. And I generally like to write my proportions this way because it's a little bit easier just to think about what's the relationship here. What's the relationship back and forth between the numbers? Miles and minutes, miles and minutes. So cross multiply 3.5x equals 40 times 8. And 40 times 8 is 320. So 320 divided by 3.5 is definitely not a whole number. It says 91.4, and I had to round it off, so I'm going to make it a squiggly equals. So 91.4285714, and so on and so on and so forth. So it should take about 91 minutes. 91.4 minutes to be exact. So a little bit more than 91, or a little bit less than 91.5 minutes-ish right there. But that's it. That's all we got for proportions. We'll see lots of types of problems to use them, and there'll be a nice percents video up for you. Probably the same day, probably today, with New Year's Eve. And I'm sorry it took me so long to get stuff up. Just try and get them done before school again on Monday. I would really appreciate it if you came in prepared. I will see you guys in class.